so I'll hop right into it. So this is going to be a talk on Onshape's best practices for FRC. So I just want to start. How many of you are already using Onshape? So majority. How many of you are like skeptical about Onshape or you're not using it? Okay, so some of you, this could be some convincing. All right, awesome. Let's hop right into it. So we'll start with who am I? So my name is Drew Bennett. My time with FIRST started in 2013. I was a freshman when I joined Orange Chaos up in to remain. During my time as a student at Orange Chaos, I was a thesis finalist. And once I graduated from the team, I came back to work as a CAD mentor and drive coach for the team from 2017 through 2022. Leading up to the 2023 season, I ended up joining Team 6329 from Bucksboro, Maine. That's the Bucks Draft, where I currently serve as a CAD and strategy mentor. Around that time, I also joined Team 3467 when you wind up as a CAD mentor and general chatter in their group chats. I just hang around to provide advice and throw a couple tips and tricks here and there whenever they need it. So what I do professionally, I'm an Onshape Education Solutions Engineer at PTC. That's a whole lot. PTC is the parent organization that bought Onshape in 2019. My role there, so I am a mechanical engineer by trade, but not really making things because I work in a software company. So I'm doing tech services, webinars and demos, stuff like this. I'm doing a lot of curriculum and content development, so things in the Learning Center, a lot of it is written by me. And I also manage our K-12 partnerships like FIRST, hence why I'm doing this. I'm also a certified Onshape professional, and I design lots of robots, hence why I have a background and am qualified to talk about this, I hope. Let's keep going. So today's topics, of course, there's so much to Onshape that I would love to talk about, but I've only got about 35 minutes because I am going to try and leave time for questions. So just some stuff I wanted to cover, some preseason setup, things to look at now before we get into the season. I'm going to do an overview of top-down design. A lot of you are already using these practices, but I really want to hammer this home as if you're new to Onshape, this is really important to get right as it will make everything much faster and smoother. And then also going to do a talk about art studios and assemblies and their performance. I know I feel like that's something I talk about a lot, is how you actually want to make sure everything loads quickly, whether it's on your students' Chromebooks or on a fancy laptop. Keeping everything optimized. Again, time is money in these short build seasons. Everything's got to load fast. We want things moving quickly. So we're going to touch on that as well. So preseason setup, aka things to think about now, not on January 4th. So first things first, make sure you and your team are signed up for the educator plan. If you have not done this, this should honestly be the first thing you do if you want to use Onshape for the season when you get back home. Why should you do this? So it's going to create a single location that's going to own all of your team's Onshape documents versus somebody makes a folder and it shares with everybody. Well, now that one person technically owns everything. If they meet the team, if something happens, all the documents go with it. In an educator plan, you can actually set up multiple administrators who have the ability to move documents, delete documents, change the names of things, change sharing permissions. So the educator plan, it's free, it's very quick to set up, it's very easy to add your students, and of course it does also add simulation and release management and more features in the future. I'm not going to elaborate on that, it's more fun if I keep guessing. There's also a blog with good instructions on how to set this up. It's a good blog because I'm the one that wrote it. I like my own instructions. Another thing you can do before the season is look at your document staging. So of course, you're not really going to be CADing anything before the season, but you can get the structure in place. Going back to Dave's talk, you can start looking at those systems before you need to actually get going. So here's a picture on the right. This is what Team 6329 did for the 2024 season. You can see our structure is very simple. There is the top level robot document, A0000, and then of course all of the subsystems that ended up making up that robot. So of course, recommend set up a clear top-level document that's going to contain your driving sketches and the top-level assembly, and then have a document for each subsystem. So in this case, it was 4 sub-documents. And of course, make sure that everybody has access and can see the documents. It's not fun to be dealing with sharing permissions once the season's going. So again, you can do that now. You can make sure everything is set up as part of your educator plan. You can do right now and start practicing. Parts libraries. How many of you are already using MKCAD or one of the provided parts libraries? Looks like most. Okay, so you already know about it. I just wanted to make sure everybody does. So there is both the MKCAD library app, which you can add to your account, and that is the menu that's right here. That's what that looks like. But you can also label the the individual documents because they're public. So instead of just using the app, you can actually use the insert dialog that is standard in Onshape. I like having both. There's some times where I prefer to insert things using the insert dialog, and there are great instructions on how to do that on Onshape for FRC.com. If you're not familiar with this, definitely go check that out. Also, a copy of this presentation is public. You will be able to grab it at the end, so if you want to reference back to any of this, you will have it. Something else I like to talk about is create a document or multiple documents almost as a team library of parts. You know, Jim Johnson talked about earlier, there's a lot of neat parts that are sort of individualized to 88's needs. You know, that's not going to be in MKCAD, but it's something that they're going to use year after year. Instead of remodeling those every year or re-importing them from McMaster, set up an Onshape document where you set the weights, you set the appearances, set the names, so that every time you want to use those common parts, you can just bring them into your robot assemblies and you're not wasting time. It's also great to make sure everybody's actually using the same parts. Relatively new website that popped up, I'm not sure if everybody knows about this, is frcdesign.org. They have a lot of interesting links to simplified models like this. You can see, here's a very simplified version of a Mark IV-I, so if your team has any, assembly loading issues, performance issues, you don't need all the gears in your swerve module. It's a COTS component. Swap it out with a simplified model. It's going to help a lot of load times, something to think about. Also, Crayon CAD. How many of you are using Crayon CAD or a similar brainstorming tool? Okay, so there's also some knowledge about that. Yep, as you can see, I see some hands from Wyndham in the back. Your picture is up here. Thank you, much appreciated. So while it doesn't really fit as a preseason tool, it is great to get familiar with it now because it's really configurable. It can be a little overwhelming if you just go into it, on kickoff day trying to, brainstorm some ideas. So definitely, especially younger students, I'd recommend they go take a look at this because it's super useful because it's heavily configurable assemblies that you can throw together in like 5 minutes to show a general robot concept. And I especially like it for younger students that might be afraid to speak up or they don't feel like they have the ability to go up to a whiteboard in front of the team and draw everything out. It's much easier for them to make a space plane model, make something that basically explains itself, and then put that up on the board. It gives students the confidence to show their ideas and put more thought and really flesh it out and see if I want to do an elevator and an intake and an impact. Is it actually going to fit or does it just fit in my head? So let's actually take a look at that real quick. So I've got an Onshape document here. So this is what a Crayon CAD swerve part looks like. So the way that this works, so let's say, the game has come out, it's reef skate time, it's an elevator game and you probably want like a roller claw or something, maybe like a 2018-ish style robot. How would you very quickly show some space planes for this? So you can insert from Crayon CAD. I'm not going to use the app. You could also keep it over here because they are in the app. There you go. You can see you've got it all here. So I could just go grab, if I can read. So let's look. So you can see an elevator. Awesome. So this is super simplified. It's going to load like that, but you can set up however many stages you want. You can set up the different heights of the elevator so you can actually move it up and down and see, collapsed, how tall is it, extended, how tall is it. You can add in mounting points and all of these very configurable things. And once you want to drop it in, drop it in. If I wanted to add a roller clock, it's the same concept. So you can roll this down, grab a roller clock. Of course, you can set your wheel diameters, the number of wheels, how far apart they are. You can drop this in there. Just a couple simple mates. You can fasten this there, fasten this to the drivetrain, and boom, you've got a general robot concept that you can then show to other members of your team and explain, this is what I'm thinking. It would, fit the height restrictions. It's not going to go outside the frame. Like this general concept is possible to execute on once we actually add more detail than a couple, cylinders and rectangles. So I really do like this as a concepting tool. I think everybody should get familiar with it. It's definitely something to learn before the season starts. And after listening to Dave's talk earlier today, I did think it was worth bringing up, systems. Set up your Onshape systems and Onshape-related systems now. Make sure that you're going into the season with an understanding of what's going to happen. I had a great conversation on Chief Delphi the other day with someone was talking about how do you manage exported DXF files. You want to go from Onshape to a router. Who should be downloading those parts? Should it be the person who designed it, exports the DXF and puts it into a spreadsheet? Is it up to the manufacturing team to go in and find said part and download the DXF? whatever workflow best fits your team, it's best to establish that now, set up your standard operating procedures so everybody knows once it's crunch time, you need to start ripping out parts on the router, who is responsible for what, so the right parts get made in the right quantities with the right materials. Also establishing design feedback. Dave gave a great example of how you can do that with Slack. But I did think it was also worth pointing out, I'm not sure if everybody is familiar with what you can do with Onshape comments, but they are pretty powerful. So every single document on the left side has a comments panel. You can open that up. And what's pretty cool is you can assign action items. So like I'm just going to assign it to myself. I can add Drew, and I will add myself. I could say, make sure this gets fully finished by end of day. Cool. I can assign that to myself, and I can also do things such as add a markup to it. So they were talking about, sometimes it's nice to just draw some scribbles. Whatever's in your viewing window, I can use the markup tool, and I can go and I can draw, and I can be like, yep, that right there, or I can add text. When I click the green check mark, it's going to add it as a JPEG to the comment. Because it's been assigned, if I were to assign that, I will actually see in my action items over here, it'll pop up there as something that I'm notified about, and I can click a check mark and let whoever assigned it to me, let them know that I did it. So you can do a lot of these processes of giving feedback, tagging items, saying, hey, has this been 3D printed yet? You can do that inside of Onshape if you take advantage of Onshape comments. So a lot of cool functionality there. Another one that I'll show you is tag entities. So this is really nice. Let's say you see something in the design that's not going to work. You can tag a specific part. It's cool too because if you zoom way out, you're lost in space. You can actually click on that and it's going to zoom you back into exactly where you were when you saw it. So if there's a very specific angle you have to be looking at to see that a bolt clearance is going to hit your intake as it goes by, you can make sure that everybody else is also able to see that. So Onshape does have some pretty solid communication tools built in. Definitely take a look at them, figure if that fits into your team's workflow. Then of course, it's also worth mentioning, figure out who's going to own each subsystem. What's worked really well with 6329 is that there is a student or someone who is responsible for each subsystem. Usually a different person or the most experienced CADer is responsible for the top level as well. But it's really nice to just have a point of context that what's going on with the intake. It's very clear who owns that assembly, who owns those models. I'm going to be on time. That's really solid. Okay, let's keep going. Top-down design. It's complicated, but it is good for you, I promise. Give it a chance, it'll work. So what is top-down design? From a very high level, it is starting from a series of sketches and adding more complexity as you work down your feature tree to achieve a final assembly. So shout out to 6328. I stole their model because I think their driving sketches are wonderful. The way they broke down the sub-assemblies are great. And most importantly, every step of this process is public and it is linked in the larger presentation that I'm going to be showing at the end, which you can QR code to. So if you want to take a look at how they did this, also how Rath has done this, it's all public. You can really drill down and take a look at it, do some great learning from that, and there's a different process you can see for yourself. So probably the most difficult part of top-down design is figuring out how to do the driving sketches and when to start on the driving sketches, which I struggled with for a couple of years. I still like doing in-context design or just not really doing a driving sketch until finally just decided I needed to figure it out, just brute force through it, and now I'm actually a big fan. So what's most important is once the team has actually prototyped and proven mechanism concepts, up until that point you can do some ugly CAD where things are a little bit sloppy, rough around the edges, things aren't organized. Just get things to the router, do your prototypes, figure out your processes. Once you know that, yep, we're going to have an arm or an elevator, we're going to have this type of flywheel shooter, and it's going to have an intake with this amount of compression at these heights. That's when we move into the driving sketches. That's when you're going to build out things like this. And again, you can see this is the driving sketches for 6328's robot. And what are you mostly looking to capture? Looking to capture things like drivetrain dimensions, mechanism mounting locations, pivot locations, anything that basically has bearing. You want to make sure you know where all the bearings are for your intake rollers, for your flywheels, for your handoff. That is the most critical structure of a robot. So that is what everything else needs to be built around and make sure that everything ends up in the right location. So when it all comes together, it actually works like the prototypes did. Also like to say, draw the sketches as they actually are in real life. And what I mean by this is use the top plane, the one that is on the XY axis, use that as your floor. I've actually started renaming it from top to floor, so you can just rename the default sketches, the default planes. And use that as the bottom, so then, you know, for example, you can see, and Susan did that as well, where their drivetrain, the tubes that they drew from the side are the correct distance from that floor plane. And they've also got it centered about the origin. This is really nice because it makes the measurements super easy. At any point, you can measure from that floor plane to anywhere on the robot, you'll know exactly how tall it is. You can also do really easy dimensions, like from where the center of the robot is to any point out in space. And I also really like it if you center it about X, Y, because by default, when you do, you know, you select everything in the assembly and you do mass properties, it's going to tell you the center of gravity about the origin. So if you've got a center about the origin, it's extremely logical to see, you know, I've got an X value of 2 inches, okay, my center of gravity is forward by 2 inches. So, you know, making sure everything's centered and actually referencing those planes correctly, it just makes the numbers and the math a lot more logical down the line. It's top-down design, how you actually make those parts. So once you've made the sketches, you're going to derive those sketches into each part studio. I'm going to explain part studios more in a little bit. I'm sure everyone knows those processes. And that's where you're going to do that in each subsystem document and then start building up the parts. So you can see here examples of that. Citrix has, you know, their drivetrain right here, parts of the arm structure right there, parts of the intake structure right there. So not trying to make everything in one location, but it is all referencing back to those same sources of truth. So once it all combines, it's going to combine seamlessly because it's all referencing the same things. So major benefits of doing this, like I said, everyone's working from the same source. You know, you're never going to have, you really shouldn't have things that come together and have major, you know, world-ending collisions on the robot. Parts are modeled where they need to be in space. If the driving stage updates and you've done proper parametric practices, you can actually have some flexible parts so that things will update if you need to stretch the drivetrain, you need to compress the drivetrain, you're trying to make your pivot point move up or down. You can do that by changing the sketch, which then will cascade down to the parts. Also makes assembly so much easier, which I will show in a little bit. So let's actually take a look at the 6328 robot. Got to refresh. Onshape does refresh like after 15 minutes of being idle, so 15 minutes. So you can see here are their driving sketches that they did. And it, you know, again, there's a lot going on here, but it's ultimately not that complex because all they've really done is, again, set up their planes. You know, they are referencing the origin as the floor. And then each of these sketches is just an offset plane and another sketch, an offset plane and another sketch that is capturing the major locations from their prototypes, again, bearing locations, flywheel locations, where the tubes need to be, where the pivots are. So, you know, it is intimidating. I found it very intimidating. But especially if you go and look at other teams, how they've done it, it does become pretty clear how to do it and what is most important. And you can see as well that derive I was talking about. So if we go to their arm, let's take a look at that. So you can see the first thing that was done in each document, so what's up, is that it was using the derive tool. They pulled it in from the other document. You see they super derive, so they bring in all of those sketches, and then all of the parts that are unique are using the sketches as like the planes and everything. So it's very simple to see, you know, how they took the reference sketches and then built them out to actually be parts. All right. And the actual Onshape document flow, I like this diagram because I think it does make it relatively simple and consistent with something you can show your students when they're trying to like really wrap their head around this, of how this works. So you've got your top level document, you're going to create that. That's where your sketches are going to live that define the robot. You're going to derive those sketches into each part studio in subassembly 1, subassembly 2, and subassembly 3. However many you need, you're going to derive those sketches in, you're going to make your parts, you'll put them into the subassembly. Once all the subassemblies are good and done, you will insert them back into the top assembly, and the robot will just magically appear in front of you. The magic of CAD. We love that. So that's, you know, a simplified way to look at the flow and generally understand how many different documents you're going to need and how things reference each other. Cool. All right, so let's talk about Part Studio performance now, and just Part Studio in general. So of course, if you've come from SolidWorks or Inventor or Creo or other modeling softwares, you know that one of the major differences of Onshape is that you can create very easily multiple unique, discrete bodies in one modeling environment. So when you make your sketches and you click extrude, you have the option to add or have a new part. And of course, you just build out your parts list, which is super powerful because then you can make things like this that look like an assembly, but this is actually just the part studio. This is just how it was built up, and this was great because we knew that this plate was where, in reference to that plate, so we could just run pieces one by one across and just do an up to face. So if the shooter changed dimensions, wider, narrower, everything else that depended on that just automatically updated in length. The shafts updated in length. Everything was driven by that top level geometry. So it was super simple to just know that it was going to fit the first time. You were not making a file and saving it, making another file and saving it. But of course, the flip side to that is you are going to end up with a much busier feature tree because you're making so many more parts in one location. So staying organized is key. So make sure you use feature folders for parts and use the rollback bar to keep features for the same parts together. I'll demo that. So just let's take a look at some different examples so you can see some good organization on the left. What makes it good is that some of the features are renamed so you can very clearly see what is going on there, and the features for any given part are in the same feature folder. So you can see, this is for the shooter plates, this is for the cross tubes, and of course if you know the robot, you generally know what these parts are, and it matches the names that are down here. So that's great. It makes it super easy for anybody else on the team that needs to go in and figure out what's going on, try and make some changes. It's pretty clear where they need to go to make those edits. If you got some organization, you can see there's no feature folders here, but a lot of the stuff is renamed. As a giveaway, this was from 639's Alpha Robot. So you can see we did spend a ton of time on the organization, just enough to be dangerous and know how to fix our prototypes. Then of course you can do no organization where nothing is renamed, and it's basically impossible. If you're not the one that modeled it, good luck going back and figuring out where to go to edit anything that was created by somebody else. So, again, this is such a collaborative process. It's very rare that only one person is going to be working on that sub-assembly. So setting up those good organization practices is super important. And let's go back to Onshape real quick, and I'll show how we can work on do this. I have so many tabs open here. Show this up. I guess Breaker works. So, of course, to rename features, it's very easy. All you need to do is just right-click, rename. Very simple. Feature folders are also very easy. Just select the features that you want to add to the feature folder and click New Folder and give it a name, and it'll just put them all in the folder. So it's very simple. Moving features in and out, you can just drag them in and out of the folder to keep everything together. And of course, the rollback bar, the way that works is, this is essentially just an equation that is building out step by step to create these parts. So if I wanted to go back and change these snap-on spacers, something about it, I would not want to just start sketching and making new features because then it's going to end up at the bottom. But it was referencing everything else up here. So what's the best practice to do is open up that folder, right-click, roll to here. It's going to hide everything else before it. Now when I make a new sketch, it's going to stay in that folder with everything else. So it's super logical that anytime I'm making those changes, it's just staying with the rest of the features that are for the same part. So, it takes a little bit of practice to get used to that process, but it just makes it so much simpler for anybody else to come back and make and execute parts. And of course, there are some exceptions where maybe, you have some part interdependencies where you can't really roll it back without losing the thing that it needed to reference. So at that point, again, just logical naming, feature folders, do your best to just make sure that anybody that comes in can figure out what in the world has happened in this part studios. Roll it back to end, and close that up. Awesome. Back to the presentation. Let's talk about Parts 3D performance again. This is something I feel like isn't covered a ton, but I know a lot of teams, especially as the robots get more complex, things might slow down a little bit. That's just the nature of CAD. That's the nature of using any the software tool to model robots. So, what are some of my general tips and tricks? And again, this is both for me. I work for Onshape, but this is also just my experiences using the platform a lot. One general recommendation is try to keep your features to less than 250 in any one given part studio. That's not a rigid requirement, but it's like a good suggestion, just a baseline. One that's a little bit looser is trying to keep your parts to less than 20 in any part studio. As you can see, the picture right here does have 39 the entire thing loads very quickly, so it's not much of an issue, because of course it's never just as black and white as no more than 20 parts. If you've got a part studio of 20 hex spacers, very simple geometry, it's going to look great. If you've got a part studio of 5 extremely complex, very curvature-heavy parts, it might load slower. So what that ultimately means is the most important thing to watch out for is your regeneration time of the part studio. Try to keep that to less than 10 seconds. Let's elaborate on that just a little bit more. So the way that you can check that is in any part studio, there is going to be this little stopwatch tool, and that is the show regeneration time tool. So when you click that, it is going to open up a menu that shows how long it's taking for each feature to build out. Common culprits for that: tube converter, love tube converter. You know what tube converter is, you should shut it off at the end, your Q&A period. But that can take a lot of time because you're putting thousands of holes into parts. So that can generally be a culprit of loading times. Things like adding in spur gears or pulleys that you're then going to further modify, that's a common one because again, spur gears, pulleys, a lot of complex geometry, lots of splines on the bottom of the teeth, any type of complex patterns and complex sketches that you're doing on different faces with imprinting on. As the imprinting gets brought into your current sketch, that can also cause some slowdowns. So as you're modeling parts, just generally do some health checks on your part studios, check your regeneration time, see what you're getting up to, and see if you see any parts in particular are causing slowdowns. Actually, so I got a message from Dan Carroll, 131. He was talking to me, and he was like, we modeled our robot, they've a ton of amazing practices. Their robot is very well organized, very well put together, but it didn't load super fast. He was curious as to why it wasn't loading very fast. So, I spent some time looking at it, and I came up with this system. Of course, it's something I came up with for this presentation. You can take it or leave it, but I do think it does a good job of explaining what is going on and how to break it down. So there are usually parts that you don't need to have in the same part studio. It's nice if one part studio for the whole sub-assembly, that's great. Sometimes you just don't need to. So the primary parts of any given sub-assembly are the critical parts that are driven by the master switch. So that is going to be your main arm tubes or your main shooter plates, the things that are the most critical defining parts of any sub-assembly. I like to call those the primary parts. They reference your driving sketches. Your secondary parts are usually the things like, pieces of 1x2 that connect set important parts, or your standoffs, or your hex shafts, things that do rely on the geometry of that part studio, but are not, driving. They're sort of driven by other parts, the sort of intermediaries. Now, the tertiary parts are the things that we like to throw in there, like pulleys, like gears, like extra 3D printed fun parts, that they're nice to have in there, but they're not relying or they're not driving any other geometry, and they can generally be created on their own. So again, things like gears, pulleys, camera mounts are good examples. So I pointed out a couple like the pulleys and the bevel gear. They don't really need to be there. It's nice that they are, but they don't have to be. So if you want to move them out, how do you do that? So as an example, what you can do is instead of making it in your part studio without any references, you can derive the same way that you derive sketches into your part studio to start. You can also derive parts from one part studio to another. It does saves a ton of loading time, but it does give you the parts that you need in the correct locations to then build more parts. So as an example, this is their shooting system that was on the elevator of their 2024 robot. I took a look at the loading time, and this bevel gear was actually taking like 4 seconds. And yet it is such a small component of all of this. When you end up breaking it out, the regeneration time goes way down by just moving the bevel gear into its own location. So again, it'd be nice if it was all there, but if you're running into regen times, things are slowing down, you can just move it out, derive the references you need, and leave it in a separate part studio. All right, let's keep going on time. Nice, we're getting towards the end. Assembly performance, this is another big one. So of course, you know what assemblies are. Once your parts are modeled, you're going to combine them with all the cost components that you're going to get from your master or the CAD library, any of the vendors. You're going to make your sub-assemblies. Your sub-assemblies come together to make your finished robot. And once you've got the finished robot, it's very nice because you can do things like measure the COG, check for all of your clearances, plan for electronics, maintenance, and of course, most importantly, take screenshots for your tech binder. But it is important, I've seen some teams, the way they model, their assemblies take forever to put together, not to load, just for them to physically put all the parts together, and other teams can do it very quickly. So what are the tips and tricks there? So the most important thing that I've found over the years is that insert all of the parts from one part studio together at once where they need to be, and then just group them. If they're in the same motion, like connection, like let's say you've got your flip down intake. All of the parts that are stuck to the robot should be one group, and all of the parts that move for the intake should be a second group. And of course, you can also then add a main connector to the instance origin, and then tie it to the origin, and then just like that with a group and one fasten mate, you can generally have all of the custom components for an assembly stuck together. They will, parametrically update if the part studio does, but it just saves an ungodly amount of time. So let's take a look at that real quick. So for example, let's do where do we want to be? Here's your example. So this is, the custom parts for a Mark IV swerve chassis. We've probably all modeled this before, and of course you could sit here and you could insert all the parts and fasten between the belly pan to this, to that, but it's just like a total waste of time. Because what you can do instead, if you insert, and I will just drop in all the parts at once. Of course, if I go into space, I can see it's moving around. If I stay over the menu, it's going to drop directly on the origin where it's modeled in the Part Studio. So just click on it, click check, and pretty much all you need to do is select it all and group it. That's it. Now all the parts are stuck together. Now they are still able to free float, so what you can do is you can either in the Part Studio make a mate connector that is at the origin, or I hide this one, and let's say, I don't have one there. I can right click, say on the belly pan, add mate connector to instance origin, and then I can tie that to the origin, and just like that, this is now ready to have all of the swerve models and the electronics added, and then it's ready to go. So it is very, very fast to put this together. And the same thing applies to intakes and shooters. When you drop that all together, you can select it all, group it, add in your motors, your pulleys, your custom components, and then you're good to go.
I assume when you move things in the Part Studio, that also...
Yes. Yes, it does. If it all comes from the same parts, so like let's say I changed it. I'm not going to change the dimensions on this because this is the actual robot model I'm messing with. So hey, I'm trying to be a little gentle with it. But yes, if I was to change the dimensions, it would just adjust. Yep. Yeah. So I love the drift tool. It's definitely something to play with too, just get familiar with how it works. But again, this is so much faster than sitting there and fastening between each part to each part. You just don't need to be doing that.
When you build this up, then you're using real mates. How are you teaching when you're pulling it in here? I'm trying to figure out one of the problems I run into is the kids will build it up, but they don't mate it together, and so they haven't really error checked.
Okay.
And then they group it, and then you get 3 steps down the road and you go, wait a moment, this is not real. Did you check your work? Did you actually align it? How are you making sure this aligned with that?
Yes. Which is why I like to say you should group as soon as it comes in from the Part Studio, because then it is just how exactly it was modeled. If you are bringing it from multiple Part Studios and you're doing group mates, I would not do that. I would actually just use defined mates to do that, because that actually fully defines the position. But if they're modeled next to each other and you don't touch it, you just drop it in there and you group it, then you are good to go. So it is.
They model it next to each other and it's still effort. It's like you didn't actually know how this is related to that. Nothing is constraining.
Which is why the driving sketches are important. So once you get the full process implemented, it does take some practice, and it's definitely, again, something to check out before the season starts. And if you can implement it, it does really work. All right. Let's wrap this up and then hopefully have some time for other Q&A. Assembly performance. Yeah, let's get through this really quickly. So top level assemblies of robots can become very slow. I assume everybody's probably dealt with it at some point. It does happen. So what really are you fighting? You're fighting the number of unique parts and the number of primitives. So also note that when you are doing, the cross, when you're you make a sub-assembly, you insert it into the top level, that does load faster than making everything in one document, because it is loading a version of the assembly, not the live assembly. If you are inserting assemblies into assemblies in one document, when you make a change over here, it doesn't instantly show up over here. You don't have to do versions. Versions do load faster, so a little bit hand-wavy there, but that's another advantage of the multi-document structure. So real quick, primitives are the triangles, the edges, basically that is the defining geometry, what your screen has to render, or what your GPU needs to render, and also if you have multiple GPUs in your laptop or computer. Please make sure that Chrome or Firefox is set to use said GPU. Like, it's sometimes a pain in the butt to get it to use the right one, but it does make a massive difference in performance. So if you got that, go make sure that Chrome is using the right one. Sweet. There's no hard limit for any assembly, but under 5 million is good. That's what I aim to keep the lightweight field under in Onshape that everybody uses. And to reduce primitives, you can do that from the tessellation quality in the appearance panel. So if you are in a part studio, let's do that real quick. You know, you can right click and I'll grab the right thing. There we go. When you do a edit appearance, you know, tessellation quality is auto. It says fine. You can turn that down, and that does, you know, adjust how much your GPU needs to work. And then you can turn it back up to the assembly level. I'll go to the assembly. Let's say you want to take like screenshots or something. You can right click and use best available tessellation. It just bumps the quality back up. So you can kind of do that very quick. Cool. We do have about 5 minutes left. I did want to leave time for questions. So assembly performance, yeah, let's go real quick. So each unique part does have its own data that needs to be tracked. So the number of unique parts does drive up the load time, where if it's an instance multiple times, it is just copying the instance, so that's a little much quicker. So, you know, be mindful about how many custom or unique parts you need to put in there, aka just don't put bolts and rivets in your CAD unless you know it is going to cause a collision or you're worried about causing a collision. Don't waste time putting in bolts and rivets. I promise you do not need it. Last thing, tabs are loaded in parallel in a document. So if you know, I've seen teams, they set it up where they got their top level robot in an assembly, then they got another assembly that's top level robot with the speaker, top level robot with the amp, top level robot with the speaker, what's the climb structure this year? Stage. Yeah, stage, there we go. You know, every time you do that, you are adding more load time to the entire document. So it's better to just put them in there. Let's see what I can show real quick. Yeah, so like what Situation 9 did this year that worked great is the amp and the stage and the speaker are in the top level assembly, they're just suppressed. So they're not loading, they're not affecting the load time at all until you right click and unsuppress. Now it's affecting the load time. So it's very simple to just leave them in there, suppressed. So it's just the top level assembly, and when you need to reference it to any one game element, just unsuppress it. Or you can also just put it into a new Onshape element. All right, pretty sure I'm pretty close on time. Time for questions. Anybody have any thoughts? Things you want to ask? Okay, we got a whole bunch. Sam, I saw your hand in the back first. Go.
So you touched on like parametric a little bit, and
Yep.
one of the things that I struggle with and I'm always concerned about is like if you make things that are parametric,
Yep.
we're working with students, accountability for if something changes, and that's reflected in other subsequent changes. So
Yep.
do you have any best practices? Do you use versions? Could you speak to how you try to keep that all above board?
Yep. So it is really nice if somebody is very familiar with, like, really the changes that affect all the sub-assemblies should be driven by the driving sketches. The driving sketches change so that everything else references back to that. And that's why, like, again, it's nice if you've really got your prototypes done and very good, like you're well along your path when you start establishing that, so it's less likely that anything breaks. It is tricky though, and I don't. It's up to your team's operating procedures of how you're going to establish those changes and how things are referenced. It's kind of a non-answer, but it's hard. But also again, staying organized to make it really easy to figure out what parts were broken or affected when changes are made. Cool. Yeah. Other questions? Yep.
When it's time to go to 2.5D of 3D cam,
Yep.
do you send people to 360 or is there Onshape?
Really glad I'm not wearing my Onshape polo right now. Yeah.
Okay.
Cam, of course, like I know it's been said many times, Cam is coming. There is an EVP, early visibility program for educators that's out there. I've had a chance to play with it. It's getting there. Computer-aided manufacturing, the ability to take the parts from Onshape, do your cutting paths on it, and export the G code for a CNC machine. Yes. I have to be kind of vague with it, but that is one of the things that is coming, and it's going to be good. I'm excited for it. Cool. Other questions? Yeah, sure.
So, we don't have anybody who's a teacher or anything like that. So, in our school,
Yep.
those kids that are taking engineering or engineering, they are teaching them with the SolidWorks.
Yep.
Sometimes they teach them Fusion.
Yep.
Is there an easy way for us to get kids to actually try to learn Onshape? Because even though the tool set is similar,
Yep.
but it's a different thinking. It's because the approach is so different.
Yes.
That's one of the problems.
Yes.
Because I love the fact that there's so many tools
Yes.
that's in there.
Yeah.
That makes life a hell of a lot easier. But we don't have any mentor on the staff. So the kids have to learn all that on their own. So that's one of my biggest challenges. How do I get the kids on to all this?
Yep, one of the, so of course, there are some good materials for learning at Onshape for FRC.com. There's been a couple published curriculums that I highly recommend. But the Onshape Learning Center itself, from anywhere in Onshape, if you click this icon right here, go to Learning Center, it will send you to learn.onshape.com. There are hundreds of free step-by-step resources that walk you through basically anything. So one that would be really good in this instance is, multi-part studios. This explains how to go from that paradigm of I'm going to use sketching features to make one part in one file to I'm going to make multiple parts. Am I being cut off? Woohoo! Yeah, so hopefully that's an easy answer. So I didn't leave a ton of time for questions. Hopefully some of this was useful. If you've got any questions about Onshape, want to talk more about it?
One thing that I try to do makes effectiveness is to, instead of having everything, they try to put everything in one master sketch. And what I'm trying to get them to do is, and some results is to have a master sketch. Other students subsidiary master sketches, so when someone else weights something, it doesn't weight everything, it only weights this. Because